Here we are at example 6 from the 1.2 set of notes. We are asked to evaluate this limit. The limit as x approaches 3 of this particular function. Now it looks incredibly similar to example 5, but there is one mere difference. And that is simply that the limit as x approaches positive 3 in this case. Last time it was negative 3. I'm still going to go ahead and set things up where we are breaking this up into the left part and the right side. So as you approach this limit from the left side and then also the right side. Now, if we are approaching this limit from the left side, then we have the limit as x approaches 3 from the left of our function. I'll go ahead and even just factor this. We can factor that 3 out of the top, leaving us with x plus 3.
And on the bottom, we notice that that is the difference of two squares, so that x plus 3 times x minus 3. These end up just canceling out, just like last time. So then we end up with the limit as x approaches 3 from the left of 3 on top over x minus 3. And if you go ahead and try direct evaluation here, that's still not going to quite work out. So this is a D and E, at least on the left side. Unfortunately, there's nothing more we can really do at that point. You know, nothing can be factored or canceled. Even if you tried direct evaluation from the beginning, this would not have worked. So that's pretty much all that we can do for the left. Similarly, for the right, things are going to be pretty identical. The only difference is that it's x is the limit. You're taking the limit as x approaches 3 from the right. So that's really the only difference. You're still factoring the same. These guys drop out. And now even if you were to try direct evaluation here, still would not work out. So this is still a DNE. So why is this not working? Well, the table, and especially I think the graph, really helps us out. If you approach this limit as x approaches 3 from the left, we notice that as you get closer and closer and closer and closer to 3 from the left, your negatives are getting larger and larger and larger and larger very, very quickly. So as you again approach 3 from the left, you're going down towards negative infinity. Okay. Whereas on the right side, as you get closer and closer and closer to 3 from the right, your values are getting larger and larger and larger and larger very, very quickly. We're going upwards towards positive infinity. And because they actually don't end up at the same spot, well, we can't even say that this is an infinity or anything like that, or potentially negative infinity. So as a result, the limit then, as x approaches 3, just in general, not specifying left or right, of our function 3x plus 9 all over this x squared minus 9 just simply won't exist. Now, it's really, really important, this is actually kind of the point of this example, is to look and see what value are you approaching. In this case, we have the exact same function as we did with 5. But the x value that we were approaching determined that this limit just would not exist entirely. Whereas opposed, in example 5, we saw that it very clearly went to this limit of negative a half. Okay? So you definitely have to be mindful of where you're taking your limits to. So again, that is example 6 from the 1.2 set of notes.